Sunshine, and here with Jared Bowman, and welcome to EWN Network. Let's talk about wind movement and directions of weather systems. So, the atmosphere is always in motion, most of the time, except for hurricanes. Weather patterns seem to move from left to right most of the time across the USA. The atmosphere is always in motion, and the primary direction of the weather system is mid to upper latitudes. But not all of the primary direction of weather system is mid to upper latitudes. But not all of the atmosphere moves in that direction. Hurricanes, most of the time, travel east to west because in lower latitudes, the atmosphere generally moves from east to west. The winds located just north of the equator are called northeast trade winds. And winds south of the equator are called winds south of the equator are called the southeast trade winds. And closer to the Earth's surface, the winds tend to move east to west. These are called the polar easterlies. Now, let's go to Jared in the beaches of Hawaii.
Hey, I'm Jared, and today I'm going to be talking about tidal waves from the beautiful beaches of Hawaii. Tidal waves are huge waves that can take out small cities. They're caused by earthquakes, landslides, volcanic eruptions, and very, very rarely meteor impacts. Tidal waves are very dangerous and can reach over 100 feet high and between 150 and 500 miles an hour. The tidal wave record for height is 1,720 feet that occurred in Latunia Bay, Alaska, on the night of January 9, 1958. About 80% of tidal waves happen within the Pacific Ocean's ring of fire. So if you're caught in a tidal wave, it's best not to swim. Rather grab a floating object and allow the current to carry you to safety.
Aaron, why is Florida so much warmer than Wisconsin?
Well, places like Florida are warmer than Wisconsin because of the atmospheric and oceanic circulation. Now I know that those sound like big words, but it's actually pretty simple. I'll break it down for you. The sun gives off massive amounts of heat and radiation, which the ocean soaks up. Especially in areas around the equator, the ocean acts as a giant solar panel, soaking up and storing heat, because over 70% of Earth's surface is covered with water. The ocean plays a big part in which parts of the world are warmer than others. The ocean currents basically act like a giant conveyor belt transporting water heated by the sun towards the north and south poles, and cold water that hasn't been reached by the sun's radiation back towards the tropics from the north and south pole.
But what about atmospheric circulation? What's that?
Oh, well, although most of the heat and radiation the sun gives off is absorbed by the ocean, some of it is also absorbed by our atmosphere. So atmospheric circulation is the large-scale movements of air which distributes heat over Earth. Without oceanic and atmospheric circulation, places near the North and South Poles would be extremely cold, while the tropics and places near the equator would be extremely hot.
Wow, that makes a lot of sense.
Now, since today is Friday, we have a special guest who is going to do an experiment based on this week's weather topic, which is the water cycle. Take it away, Allie!
Hi everyone, I'm Ella. Today I'm going to be showing you an experiment to help you learn about the water cycle. But first, let's take a look at what the water cycle is. The water cycle has three phases that all the water on Earth goes through over and over. First, heat from the sun evaporates the water, turning it into steam. Have you ever seen a little white cloud of steam coming off hot food? That's actually water in its gas state. Next, the steam rises up into the sky in clouds where it condenses until it turns back into a liquid and becomes too heavy for the clouds to hold, and it falls to Earth. That's the second part of the water cycle, condensation. And lastly, when the water falls from the sky, it's called precipitation, or you probably just say rain. And now the water is back on Earth again and ready to start the cycle all over again with evaporation. Now, in case you didn't get all of that, let's try an experiment. For this experiment, you'll need a large bowl, a smaller bowl, cling wrap, a rubber band, and water. First, put the smaller bowl inside of the bigger bowl, then fill up the larger bowl with water. But make sure not to get any in the smaller bowl. Now take your cling wrap and put it on top of the bowls. Take your rubber band and wrap it around the bowl so the cling wrap is tight and won't come off. Finally, place the bowl in the sun and wait for a couple of hours. When you come back, you'll see that the sun has evaporated some of the water in the large bowl because there are small droplets of water on the cling wrap. This means that the water evaporated and floated up in the form of steam, then gathered on the cling wrap and condensed into water. And you can see by looking at the small bowl with that little droplets drop down, which is precipitation. Now back to the studio.
Thank you, Allie. That was a great experiment on the water cycle. Now, we would like to thank you all for watching EWN News. And have anything to say, Jared?
Tune in tomorrow.
Bye!
Now, in case you didn't get all that, let's try an experiment. For this experiment, you'll need...
Just kidding, I'm sorry. Okay, stop it. Oh, hey, it's Aaron.
Now, take your cling wrap